Again, I want to appreciate everyone who have managed to join this session today. This is our platform as network engineers to share knowledge, network, and connect with each other, and also to empower each other through knowledge sharing. And we've been doing this since last year. Remember, we had the IP run training sessions, which we had live sessions last year. And this year we have taken a different approach where we are inviting other engineers in the industry to come and share knowledge on this platform. We've already had 3 sessions. We had the subnetting session by Eve. We then had the OSPF deep dive session by Martin Motiva. We then discussed BGP. And today we are discussing ISIS. In network engineering, we have lots of protocols, many protocols that you need to master as a network engineer. And when we talk about mastering, it's not just about the theory. You need to explore both the theory and the configurations. And this is what we are offering on this platform so that we can share the knowledge on how to handle these protocols and just interact and also learn from each other. So today we are glad to have Theophilus Bitok, who will be taking us through the session. But before I invite him to come in, just some ground rules. I hope that you will keep your microphones muted. If you have any question during the session, it's better to send it on the chat. Or if it's a very burning question, you can raise up your hand so that we can pause and respond to your question. So let's keep our videos and the microphones muted so that we don't interrupt the trainer when he's in the middle of explaining some important topics to us. That is it. Theophilus, if you are in the audience, I believe you are there. You can take it over and take us through ISIS protocol.
Yes, absolutely, Martin. I'm in the audience.
Missing. Thank you so much, Theo, for taking up this opportunity to also share your knowledge with the team. We appreciate that.
Okay, thank you. Okay, so my name is Theophilus Bitok. I also have a 5-year experience in network engineering. I previously worked in WIOC as a NOC engineer, and I'm glad I've seen some of my former colleagues at WIOC who have joined this session. I then also joined Airtel, where we were managing a IP run Airtel network in Kenya. And currently, I am in Safaricom, and I am working as an enterprise core engineer. So, without further ado, I will go and share my screen. I know we have a very limited time, and we have a lot to share. And let's make the session interactive as possible. Actually, this is a session whereby we come, it's not really like a class, but we come and share our experiences. And even before I start, I would also want to thank Martin for having taken this initiative of coming up with sessions like this, whereby we network engineers come together and we come and share our knowledges and experience. Personally, I have learned a lot, and I'm even impressed that to see even young engineers like Stanley, who is still in school, but he's already joining the session to know what is actually happening in the industry, which is really a good thing. So I'll proceed and share my screen. Please confirm if my screen is visible.
Yes, it's visible.
All right, thank you. So basically today we are going to discuss about ISIS. And as Martin mentioned earlier, ISIS is one of the routing protocols. It is an IGP, just like the way we have many other routing protocols like RIP, you have GRP, we have OSPF. So ISIS is also one of them. It is an IGP. So basically today we are going to we'll first start with the ISIS fundamentals. Then we will proceed to operation. We'll look how ISIS works, the different packet types for ISIS, how ISIS is designed, how are there's in terms of areas, in terms of levels. We are going to look into that as well. And then on the advanced features, we are going to look in route leaking. And on troubleshooting, we'll see maybe what could actually make maybe your ISIS, maybe sessions not coming up. What could be the probable causes, and then we are going to look into real world use cases, and for on real world use cases, actually this one we are going more to compare why is it that ISIS is being preferred by the service providers compared to OSPF. Just a minute, sorry. So, as I said earlier, ISIS is another IGP routing protocol, and it's a link state routing protocol, just like OSPF. And it was basically designed for OSI. And you'll find that ISIS actually uses the connectionless network protocol. So mostly you'll find ISIS is operating on the data link layer. So when I say that it's operating on the data link layer, so you'll find that let's say, for example, when the ISIS is sending its packets, it always uses a multicast MAC addresses, and we have different multicast MAC addresses depending on the level of the ISIS level. We have two levels on ISIS, that is the level 1 and level 2. So each and every level is going to have a different multicast MAC address. We are going to look into that as we proceed. ISIS is actually, I can say it supports a dual stack. And when I say it supports a dual stack, let's say, for example, you have your interface. So you can configure, if you've configured, you can configure IPv4 address and configure IPv6. And then when you enable ISIS on that interface, basically the two protocols are going to be advertised, both the IPv6 address and the IPv4 address. That is basically when I say it's a dual stack protocol. So as I had mentioned earlier, ISIS actually has different types of routers, and the router types we have, we can say we have three types. We have level 1, we have level 2, and we have level 1, 2. So for level 1 routers, we can say I can say it's usually used on the access on the access, mostly on the access layer, whereby you'll find that that router actually it just knows the routes for its own area, and it always maintains one link state database. And then now for the level 2 router now is like your core router. So it knows, like, let's say, for example, we have different areas. Let's say we have area 1, area 2, area 3. So for level 2 now, it being a core router, it is going to know how to reach routers maybe in different areas. And then level 1, 2 now is like, you can say now, if we were to like to classify them, we can say the level 1 is on the access, and then on the level 1, 2 is on the aggregation, and then now level 2 is on the core. So basically what happens is you will find that the level 1, 2 is always, it's going to send a default route to the routers in level 1, because actually, if you remember, level 1 router, let's say, for example, if it's in area 10, okay, so it's going to know only routes in area 10. It doesn't know how to get routes to other areas. But for it now to know how to get into other areas, then we'll have to have a level 1, 2 router. Now, so now the level 1, 2 router is going to advertise a default route to level 1 router, telling them, okay, you are in area 10. If you want to reach area 20, you can you can pass me. So basically level 2 router is like a transit. And then now for level 2, it just knows it knows all the routes for the different areas. If you have, let's say for example, you have 5 areas, area 1, area 10, area 15, area 14, level 2 router is going to, it knows all the routes for all those areas, since it's in the core. So basically, and when it comes to the formation of adjacency, so a level 1 and a level 1 router can form adjacency, that is okay. A level 1 and a level 1 2 router can form adjacency, but you will never find a situation whereby a level 1 router and a level 2 router forming an adjacency. No, the adjacency is going to fail. And then for level 1, level 2 can also form an adjacency with a level 2. So for LSDB, the level 1 routers only maintain one type of LSDB, that is for the level 1. And then for level 2 routers, it maintains also one that is only for level 2. But now level 1, 2 router maintains both LSDBs for level 1 and level 2. Now, the next is on the attached bit. So attached bit is actually something being used in level 1, 2 router. So you may find, for example, there's an adjacency between a level 1 router and a level 1, 2 router. And as I mentioned earlier, a level 1 router doesn't know how to get into other areas. So what will happen is you will find a level 1, 2 router sending an attached bit to level 1. And that attached bit, it's just like a default route to level 1, telling them if you want to reach maybe area 6, let's assume the level 1 router is in area 5. If you want to reach area 6, just use me. So basically, it's just telling the level 1 router, use me as a transit. Then on the placement, yeah, you'll find the level 1 routers being on the access. And then for level 2, it's going to be on your backbone. And then level 1, 2 is going to be on the aggregation. So you could be having many areas using that are on level 1. Let's say, for example, you have area 5, area 6, area 7, and you'd like those routes to reach your backbone. So the router that is going to aggregate all your routes and take them to your core area is the level 1, 2 router. So when it comes to route leaking, the level 1 router doesn't perform. It cannot perform route leaking, basically because it is just in that area alone. It doesn't know about any routes about the other areas. But level 2 router, it knows routes in different areas. So you may find it could be leaking other routes to maybe a level 1, 2 router. So this one also performs level 1, 2 router also performs leaking. So in terms of route leaking, it's only 2 routers that perform the route leaking. That is the level 2 and the level 1 router, level 1, 2 router. So let's see in a diagram. So you see, like for this one, you see the area 10. The area 10 is level. It's on level 1. So for now, let's say, for example, R1 wants to reach to R8. So R1 only knows routes in area 10. So for it to reach that one, R3 is going to it's going to advertise a default route to R2. And then now once it has advertised that default route, then the R2 is going to push that default route also to R1. Okay, telling them if you want to reach another area, just use R3 router. So R3 router comes to the core area. Now, the core area is the level 2 routers. You see R4, R5, R6 are area 49, and this is your backbone your backbone area. So basically, area 49 knows it knows all routes to area 10 and routes to area 20, being the fact that it is in the backbone. So basically, it's going to know how to reach the different areas. And then also on adjacency, I told you it's for level 1, it will just form a adjacency with a level 1 router, and also it can form an adjacency between a L1, L2 router. And then L1, L2 router can form also adjacency with an L2 router. Yeah, but an L2 router cannot form adjacency with an L1 with an L1 area. Now, so I told you for this L1 L2 router, when it always has when it's advertising, it has the attached bit. The attached bit has the default route to the other areas. So there is always something we call an overload bit. So basically, an overload bit, it usually tells it is usually it's usually used by the L1 L2 router and L2 routers. So basically, an overload bit usually actually tells the adjacent routers, telling them don't use me as a transit. So now we have a situation whereby R3 is having an overload bit telling R2 do not use me as a transit, and it's also sending an attached bit to R2. So an attached bit basically is the default route to the other area. So what is going to happen? So what usually happens is if R3 is sending that overload bit to R2, the attached bit is going to be overwritten. So basically it means that R2 is not going to know it's not going to have an idea on how to reach the other areas, assuming that, let's say, for example, it has only one link to the aggregation router, that is the L1, L2 router. So actually, the overload bit is always going to override the attached bit. And we always use the overload bit in some scenarios. Let's say, for example, you are performing a software upgrade on R3. So you have to send an overload bit, because actually maybe at some point maybe the router is going to restart. And assuming that, let's say, for example, R1 had maybe another connection to another L1 L2 router. So if router 3 is going to send an overload bit, so it's going to tell R1, okay, just fail over to the alternative link, since I don't want you to use me as a transit, because maybe I'm going to reboot in a few time. And another situation, maybe you could also implement the overload bit, is when, let's say, for example, there is maybe the CPU is overutilized at R3. So you may start sending that overload bit. But in most scenarios, I've always seen on the most of the providers, they set the overload bit on startup. Like, let's say, for example, if the router is going to start up, just send the overload bit first. So it's going to send a notification to all the other routers telling them do not use me as a transit. But remember, in fact, in as much as I've set an overload bit on R3, so what will happen is, if there are any routes that are destined to R3, or any routes that are being advertised by R3, and R3 is acting as the originator of those routes, those the adjacent routers are not going to ignore R3. So what will happen is they will still send their traffic towards R3, since the R3 is the originator. So the overload bit only affects the transit. So basically, it's going to tell it, do not use me when you are going to other areas. But for routes that are destined to me, just send it to me, and then when I restart, then maybe you are going to experience something like a black hole during the time that I'm restarting. So actually, these overload bits, I remember it's at some point it ever gave us some issues. So we had a ring, and that ring, it was a core ring, and we had a router in the middle that we, by mistake, someone had set an overload bit. So what happened is, we had a fiber break on one side of the ring. So ideally, traffic should have failed over to the secondary ring. But since that router was sending an overload bit, it was telling the other routers, don't use me as a transit. So we were wondering what could be the issue. Eh? Why is it that the traffic is not failing over to the secondary link? And if you try, let's say, for example, if you check the routes, you see it's okay. You can ping, you can even reach the router through the secondary link. And it was basically because it was just the transit, the overload bit was making the traffic not to pass. But for traffic that was destined to that router that had set the overload bit, it was it was still coming. So it's something you may, I don't know if maybe someone has ever experienced in maybe in their environments. So that is basically about the different routers in ISIs in so basically, and another thing is on route leaking, you will do route leaking on your core, on your L2 and L1, L2. And for L1, it doesn't do any route leaking. In terms of maintaining of the LSDB, the L1 routers is going to maintain one LSDB. And then for L1, L2 is going to maintain the two LSDBs, that is for the level 1 and for the level 2. And then for L2 routers is going to also to maintain one LSDB, and that is the L2 LSDB. So this is basically how you set up your levels. And for this one is actually I just based on Huawei. It's a common. So for level 2, actually it's level 1, 2 is always, it's like the default. So you can specify your level there. Size level, level 1, 2. If it's level 1, specify it as a level 1. If it's a level 2, you can specify it as a level 2. You can also do it on the interface level. So after you go to the interface configuration, and then you mention the circuit type. That is, you either will say level 1 or level 2 or level 1, 2. So that's basically when it comes to configuring your levels on Huawei VRP. Okay, so actually, iSize has it has two network types, and the two network types is mostly it's just the broadcast and the point to point. And the network type is actually very important. It enables you. It's actually it's a key thing. It helps you to decide on how the hellos are going to be sent, whether you are going to have to elect a DIS, how flooding is done and acknowledged, and whether a pseudonode is required. So let me, I can just show you a diagram. So, as I told you, we have two network types. That is the point to point and the on the broadcast. So basically, for this one, is just for point to point is just the link between the two routers, and for this one, there will be no DIS. There is no DIS election. DIS election is only done on the broadcast. And for this one, it's actually since the adjacency is quite simpler because it's actually between the one router and the like for this one is between router 1 and router 2. And actually mostly I see in a service provider network you always use the point to point network. For broadcast, I think at times it is used in data centers. And for this one, you will have for broadcast, you will find you will need to have the election of the election of a DIS. And actually, a DIS is like it's like the designated router in the in in OSPF. It's like it plays the role of a designated router in OSPF. The DIS it is same as a designated router in OSPF. So so actually, how when it comes to your configuration, is you'll have to specify the CQ type, the network type on the interface level. You can either have the point to point, or you can have the broadcast. One thing to note is, let's say for example, you have these two routers. Assuming, like for example, in port 00 on R1, and port I configure this one as point to point, and then on R2 I configure a broadcast. So basically, it's not going to form the adjacency. So that is something you may consider to check. Let's say, for example, if you have a link that is not forming the adjacency in your network. Maybe it could be you've configured different network types between the two links. And for broadcast, actually, you will find the routers in a broadcast network. They always send LSPs to each other on a broadcast multicast MAC address. And what actually a DIS does, it's like an auditor. Let's say, for example, we've sent the LSPs, and maybe let's say, for example, router 2, the DIS realizes that router 2 is missing some of the LSPs. So it's now going to send it to router 2. It's not really that the DIS is the one that is supposed to send the LSPs to all the routers. No, they always, each router sends their LSPs, but the DIS always works as an auditor. If it realizes like maybe router 4 is missing some LSPs, then the DIS is now going to send those to send that LSP. And when it comes to now, in selecting now, like you have, like in this broadcast network, you have 4 routers, and a DIS needs to be elected. So the first thing that they always check is on the priority. If you've configured the router with the highest priority is the one that is going to be elected as a DIS. But if we don't have, if you've not explicitly configured the priority in your broadcast network, then it's going to check the MAC addresses. And the router with the highest MAC address is the one that is going to be elected as a DIS. Also, still on the election of DIS, you will find that the the it's actually, you'll find that in ISIS, the election is always I think it should be preemptive, such that, let's say for example, let's say you've configured maybe another router joins this broadcast network, and it has a higher priority compared to all other routers that were in that broadcast network. That router is going to be elected as a DIS. And like OSPF, for OSPF, if one has been elected as a DR, is going to remain as a DR until maybe, let's say that DR maybe reboots, then maybe we'll have now a new re-election. But for ISIS, if a new router joins and it has a high priority, then it's going to be immediately elected as a DIS. So we have in ISIS, we have different packet types, and the packet types are called the PDUs. So the first packet is the ISIS hello. And for this ISIS hello, it's mainly used for discovery. It's neighbor discovery. You discover that, let's say, for example, there are 2 routers. So they are going to send each other hello, and then the hellos are going to be sent, and then they form an adjacency. Then after the formation of the adjacency, you will find that these routers will always send each other hello periodically just to confirm that my neighbor is still up. So basically, the hello packet is always used for neighbor discovery and also maintenance of that neighbor. So the hello packet has a has a, actually it's you understand that ISIS uses the TLVs. So the hello packet has some different TLVs. So it's going to have, you'll find on the hello packet, you'll find the area address. So if it's area 1, then you'll find it's going to be stated in that hello packet that this is area 1, and maybe this maybe if it's area 2, that is area 2. So like for example, let's say for example you are working in an let's say your two routers are in level 1, right? And I told you for level 1 routers to form an adjacency, they must be in the same area. But let's say, for example, you've configured your routers as level 1, but you've configured different areas. Let's say router 1 is area 1, and then router 2 is area 10. So when R1 receive hello packet from the neighbor and it's saying it's area 10, and R1 knows that I'm in area 1. So basically, that adjacency is not going to be formed. Another TLV in the hello packet is on padding, and padding actually has something to do with MTU. We are going to look into that as we proceed. And then there is also the authentication. Let's say, for example, you've configured the authentication. You don't want anyone to just come and form an adjacency to you with you. So you may configure authentication as one of your security measures in ISIS. Then there's also the IP interface address. So you remember, like, let's say, for example, this port 0 on R1, it has an IP address of 10.1.12.1, and then the adjacent port as a 10.1.12.2/30. So you may find a situation whereby someone has configured, let's say, for example, you've configured, let's say on R2, you configure 10.1.12, maybe .6/30. So basically, those networks they are different. So that could also be one of the reasons that is going to stop the adjacency from being formed. So if the on this hello packet that is sending between the routers, they are going to compare, is this address within in my network? If yes, then you can go and proceed forming the adjacency. Another thing, another TLV on the hello packet is on the protocol. So remember, I said ISIS is I can say it's a dual stack. You can configure an IPv4 address on that port, and you can configure IPv6 address on that port as well. So you could be carrying two addresses on that port, and ISIS being dual stack is going to advertise both. So now it's going to, when it's sending this hello packet, it may tell its neighbor, by the way, I also support IPv6, and my IPv6 address is this and this, and the other one, maybe the other one has configured an IPv6 address as well. So you'll find that the adjacency will be formed both on IPv4 and IPv6. So those are the TLVs on the hello packet, and we have also the components on the ISIS hello. We have the CQ type. The CQ type is actually the level 1, level 1, 2, level 2. So the hello packet also carries that one. The source ID. So the source ID is like you can say, like, it's like the identifier of the router that is advertising that hello packet. So and you will find actually the source ID is actually unique. It's always unique. It's always unique, unique across the network. And then the holding time. How long am I going to take before I expect an hello from you? Let's say, for example, you've configured an holding time of 10 seconds. And so basically, what I'm trying to say is, I will expect you to be sending me hello packets after every 10 seconds. And if, let's say, for example, now we'll find you before I declare your neighbor as down, maybe you're going to miss you miss 3 hellos. Then I can declare your adjacency as down. So at times you may find engineers configuring hold time between the point-to-point between the point-to-point routers, you configure holding time to be different. So actually, that could be as well. Could be one of the reasons that is going to stop your adjacency from being formed because of the difference on holding time. And then on the priority, remember on a broadcast network, we always elect a DIS. So this hello packet also has that priority. So if I have a higher priority in the broadcast network, basically I'm going to be elected as a DIS. So that is basically on
You're
the hello
breaking,
packet.
excuse me.
Hello? I don't know. Is it for every? Am I breaking for on everyone or maybe?
No, for me,
I think you're okay.
Not for me, you're clear, very clear.
You're clear. You're clear. Some of us can hear.
Okay.
Clear.
Zachary, maybe you can check on your network.
let's proceed.
Okay. So we proceed to the second packet type, and that is the LSP. So this one is it carries the full topology information. And when I say the full topology information, I mean it's going to carry all the prefixes, it's going to carry all the metrics, and all the neighbors, all the neighbors. Let's say, for example, you can take an LSP as a, let's say for example, like the capital cities in Africa. So you'll find that router will be saying, okay, I know a route to Abuja, I know a route to Nairobi, I know a route to maybe Kampala, something like that. And it's going to tell you now, if you are to go to Abuja via me, this is the cost. If you are to go to Nairobi via me, this is the cost. That is basically the LSP. So it's going to carry the prefixes, the neighbors. When I say the neighbors is those routers that I have an adjacency with. And then now the prefixes, now it could be those the destinations now, like the destination that, like the way I mentioned the capital cities in Africa. And then the matrix now is the cost. If you go via me, this is, let's say for example, a cost of 100 or maybe a cost of 200. And then for CSNMP, so uh, now we can take as a, let's say for example, you are in a library, right? And in a library there's a catalog. So for CSNP, it's actually, it has the sequence number, it has a sequence number and the LSP. So it's going to say, let me be LSP1, maybe this is the sequence number. It's just like a summary of the LSP. Let's say for example, in a library we have many books, but now the CSNP is like the library catalog. It's going to list you, okay, these are the books, that we have in this library. So it's going to list you, maybe it gives you, maybe we have this book and this, it is in this shelf, or just giving you that direction. It's just like a summary. Now the PSNMP, it's like a subset as well of the CSNP. So and I can just give an analogy of this. Let's say for example, I say a CSNP is a library catalog. But now you may find a situation whereby we've listed on the catalog that we have book A, book B, book C, book D, and book E. But when you go to the shelf, you don't find book E. So now the PSNP is going to say, okay, you've listed 5 books on your catalog, but you don't have book E. So PSNP now, it's like it's going to request for the missing resource. So the missing book E, can you bring it to the shelf? Such that whatever we have in the CSN on the library catalog, we also have the book on the shelf. So basically the PSNP is just anything that is missing is what is going to be covered on the PSNMP. And then the sequence numbers, now the sequence numbers is just like maybe this LSP is a sequence number, maybe sequence number 10, sequence number 20, something like just like that. We are going to look on the sequence numbers when we come to the LSDB synchronization, SNMP, then will make sense. So when it comes to the neighbor establishment in ISIS, it's usually 3 phases, and the first phase being the down, and then the second stage is the initial, and then the third step is now the up, whereby we have formed now a full adjacency between we have the full adjacency between the two routers. So for example, if for the down, it's basically actually the hellos have not been received, but once the hellos are exchanged, then it goes to the initial, and then finally, if we've exchanged the hellos, everything, all the parameters are okay. If exchange the LSDB, then we can say a full adjacency has been formed, and the phase will be up. So now we have different things that could stop you from forming a neighbor adjacency. Number one is matching area ID. So for the area IDs, is going to be very important on the level 1 routers. So you remember the level 1, they just deal with one area. So if I configure, like, let's say for example, R1 is L1 router and R2 is L1 router, but I configure area 5 here and area 6 here. So the adjacency is not going to be formed because we have different areas configured on the two routers that are supposed to form the adjacency. The second thing that could stop you from forming adjacency is on the levels. So let's say, for example, R1 is L1, and then I've configured R2 as L2. So for that one, it's not going to form adjacency, since actually they are in different levels. So you'll find that L1, L2 is going to form an adjacency that is okay. An L2 router and an L1, L2 router is also going to form an adjacency. But an L2, L1 router, L2, let's say L2 on router 2 and L1 router here, it's not going to form adjacency because actually they're in different levels. Another thing is matching authentication. Let's say, for example, I've enabled authentication here, and I've also maybe enabled authentication here, but maybe maybe the password that I've set when it comes to forming the authentication are different. So it's going to check on when it calculates when it checks its hash, and it realizes that the hash, maybe my local hash and the one that I'm receiving from my neighbor are different, then for that one is also going to stop you from forming an adjacency. Another thing that we have is also on actually you may find a situation whereby an MTU size may stop you from forming. Let's say, for example, we have a different MTU on this port. Let's say we have an MTU of 1500 here and maybe an MTU of 9000 here. So it may stop you. So what will happen is, I had mentioned when we were discussing the hello, the ISIS hello, you remember I mentioned on one of the TLVs is on padding. So what usually happens is, I would like you, okay, let me just give a simple analogy when it comes to padding. Just think you do have a pillowcase. So just the pillowcase without anything inside. So now when you fill the wool, then it now becomes a whole pillow. So let's say, for example, the ISIS, let's say, for example, I have configured an MTU of 1500 here. and ISIS is maybe the ISIS packet, maybe the size is maybe 1492. So what will happen is for padding, it's going to make it like it's going to add something extra on top of it to make it 1500. So once that padding has been done, let's say for example this is the MTU here is 1500 and the MTU here is 1400. So it's going to send a packet of 1500 to R2, but R2 has an MTU of 1400. So what will happen is actually you'll find I don't think ISIS usually supports in terms of like the fragmentation. Like for example, it has received a bigger packet than the one that it was expecting. It won't really subdivide, let's say subdivide to make it into so that it can fit on the MTU configured here. So what will happen is the adjacency is not going to be formed. That is when if you've enabled padding, and this is actually very key when it comes to, let's say for example your network is actually expanding, and as the network is expanding, when I say the network is expanding, let's say for example the number of routers is increasing in your network. Let's say initially maybe you had 5 routers, maybe you now have 100, maybe 200. So you will find the size of the LSP is going to increase. And you may find like maybe the LSP now, maybe it might increase. Maybe you will be sending maybe a packet of, let's say 6,000 bytes. And let's say, for example, on your maybe one of the routers along the link, maybe it is using a smaller MTU. Let's say, for example, using an MTU of 1500. So you may find some of the LSPs are being dropped just silently, just because of the differences in MTU. So for best practice in ISIS, it's important for you to enable padding such that if there is any variation in terms of MTU, then that adjacency fails to small. But at times you may find engineers, maybe they may find a way, they may use the ISIS small hello. So basically the small hello, it's just going to send the hello packet without the padding field. So for that one, you will still find the adjacency being formed regardless of the differences in MTU. But now what you may find in future now is like you may have issues, like let's say for example an LSP is being dropped just because maybe the MTU size is smaller, but you will still check. And when you check, you ask yourself, okay, my adjacency is up. Why is it that maybe some networks are not being propagated? It's because maybe some of the LSPs are being dropped due to the different MTU size. And the last thing that could stop you from maybe forming an adjacency is on the bidirectional communication. And on bidirectional communication, let's say for example, maybe there's a fiber cut here. So you will find that the point to point will basically be, it's basically down. So if the physical link is down, then it means that your ISIS is not going to come up. So the next thing that we are going to check is on the LSDB synchronization. So okay.
Yeah, you can take a pause, and there are some questions on the chat, just so that maybe we can handle some few questions before you proceed.
Okay.
Doreen Njeri was requesting that you go back to the PDU type slide. I don't know whether she has information on that. Doreen? Maybe she just wanted to take a snippet. The slides will be shared with you, so don't worry about that. And then Avi is asking whether L2 and L2 can form adjacencies.
L2 and?
L2.
L2 and L2 is going to form an adjacency.
Okay. Okay, I think the last part you've already discussed about this, but he was also asking in what conditions will two routers not form adjacencies?
So when it comes to forming adjacency, let's say, for example, the different, let's say, for example, you have two routers L1, L1, and you have mismatching area IDs. So that one is going to, it's not going to form an adjacency. Another thing is the type of the network type that you've configured. If you configure one side as a broadcast and the other side as a point-to-point, that is also going to stop you from forming an adjacency. Also, the IP address configuration. Let's say, for example, you configure an IP address, maybe a /30, 10.112.2/30.2 maybe, and then you configure another one, maybe 10.12, maybe 3 dot something. Those are two different networks, so that is also going to stop you from forming an adjacency. Another thing that could stop you from forming an adjacency is on also on MTU, especially when padding has been enabled. Another thing that could stop you also forming an adjacency is on the timers. So let's say, for example, you've configured an holding time of on router one as 10 and then the other one as 30. That is also going to stop you from forming an adjacency.
I believe also the interface type, if you configure one side point to point and the other side you've configured broadcast, it will also cause an issue in establishing the adjacency. And some of these things, they're actually vendor specific, so you may need to do the simulation on the different vendors, and then you will be able to establish why the adjacency fails to come up. The last question that is on the chat, the role of DIS is just like an auditor. Does it share the routes to all routers or just check the missing one?
It just checks the missing one. So what happens is you may ask yourself, how does those routers on a broadcast network avoid a collision? So they'll always have, they have like a timer. Let's say, for example, a router one maybe sends, let's say a timer of 3 seconds. So maybe router one starts sending its LSPs, and then router two follows sending its LSPs, router four sends its LSPs. And then if, let's say, for example, the DIS realizes like maybe one of the routers is missing some of the LSPs, then now it's going to now send that the missing LSP to that router. So it just acts like an auditor.
Okay, last one from Avi again. You mentioned that ISIS is a layer 2 protocol, and he understands that from this, then it will not be checking the IP address. So why is it that if you have misconfigured the IP address, the adjacency will fail to come up?
So when I say it on layer 2, it's when it comes to sending the hello packets, it usually sends it on the data link. But remember, on one of the when you are sending when the router is sending the hello packets, it has a TLV of an IP address. So it's going to check. It's going to check that IP address if they are matching. And remember, actually, when ISIS came up, it was actually not designed for IP. We came and integrated it to support IP later.
Okay, yeah, I think that is it for now. We will revisit the questions in the next break. You can continue with the slides and then we'll note down any other new question that will be coming in.
Okay.
Martin, your hand is up.
Yes. You guys hear me?
Yes, we can hear you.
Yes. So let's say, for example, there is the TLV suppressions on the LLDP. How will that impact the negotiation on two routers when it comes to ISIS, and which uh, TLV value or values are used for the negotiations for ISIS?
So for most of the TLVs that are used for negotiation is basically actually I can say the area address for the level one, and then also the authentication and also the IP address. Now, ISIS, being the fact that it supports TLVs, so you may find at times, let's say for example, a router does not support maybe some TLV, maybe it's being supported maybe from a different it's okay, that TLV is supported by a different vendor, but maybe on this router that is forming an adjacency with it does not support it. So you'll find that router, it will just silently ignore that. It will just ignore that TLV.
So I just need to understand this terminology.
Hmm.
So the TLV, is it referring to the type length value on LLDP or CDP if ISIs is run on Cisco, or is there another TLV that is specified in ISIs? I just need to understand the two.
Then maybe you can try. I haven't gotten your question exact clearly.
So for example,
Hmm. Hmm.
on Cisco you can configure uh, a TLV or a type length value in a Cisco switch to suppress certain values with that's coming from the TLV for security,
Hmm.
and then same applies with the LLDP. So my question was that is the ISIS TLV referring to that TLV on layer two, or is it the TLV that's specifically on the ISIS protocol?
No, the TLV, it's the TLV on the specifically on the ISIS protocol.
Okay,
Yes.
cool. Okay, well, thanks.
Thank you. Any other question?
Let's proceed. We can have other questions coming in later.
Okay. So the next thing that we are going to do is on LSDB synchronization, and basically uh, on LSDB synchronization, it's actually what it tries to achieve is to ensure that all routers have a consistent link state database. We don't want to have a situation whereby maybe a router says, let's say, for example, knows that I know a route maybe to reach Kampala, and maybe the route that he or she knows or is preferring, maybe the link has gone down. So we don't want a situation whereby we may find our traffic being black holed just because our router is holding on an old LSDB. So it's just to make sure that if any link is down, let's update on our LSDB that this link has gone down. If we have alternatives, then now we may say this is now our best route to reach maybe router X or maybe router Y. And you will find these LSDBs, they are always flooded either within the area or within the domain. So when I say within the area, let's remember the routers in the level one routers, they know the routes just within the area and maybe a default route to the transit routers, that is the L1, L2 routers. So you will find that now an L1 LSDB is going to be flooded in just within that area. But now for L1, L2 or an L2 router, those being the core routers, then the LSDB is going to be flooded across the domain. So basically, we have for when it comes to LSDB synchronization, we have two types of synchronization. We have the triggered synchronization, and we have the periodic synchronization. So maybe I can just give an analogy. Let's say, for example, for the periodic synchronization, let's say you have an alarm in your house. Okay, so for periodic synchronization, maybe that alarm is just going to ring just to tell you that my batteries are okay and the system is okay. So for this one is actually just going to it's just going to be sent periodically, maybe after every 30, maybe after most for ISIS, I think it should be after every is it I think 20 minutes. So you'll find like let's say if I send my LSPs, then it's going to have a lifetime of the 20 minutes. Then I'll expect that one to be resent again. But when you are sending the periodic synchronization, the periodic synchronization, you should note that the sequence number is not going to be incremented. It's not going to be incremented, and there will be no shortest path. The paths, there won't be any recalculation because nothing has actually changed. I'm just sending to tell you, okay, whatever I send you before, the network is still just like that. There has not been there is no link that has gone down. It's nothing. Everything is just okay. It's just to tell you that the status quo remains. And periodic when it comes to periodic synchronization is also actually there hasn't been any change in adjacency. And then now we have the triggered synchronization. So the triggered synchronization will happen if, let's say, for example, maybe one of the link has gone down. So I'm going to resend now my LSPs telling my other routers, okay, I knew a route maybe to go to Nairobi, and the route that I was using was X and Y, but maybe that link has gone down. So I'm going to send an updated LSP telling them, okay, I still don't have maybe I have the route, maybe my preferred route to reach Nairobi is this and this because maybe the other one has gone down. So for that one now, it's going to trigger the recalculation of the paths. Another thing that could cause the triggered synchronization is, let's say, for example, let's say for another router, maybe reboots or anything happens. So that one is actually going to force it's going to force the triggered synchronization. Another thing that could make the triggered synchronization to happen as well is, let's say, for example, I reset my SIS process. So if I reset my SIS process, then it means I'm going to trigger a resynchronization of the LSDBs. So this is like a diagram, just representing the LSDB synchronization in a diagram. So the PSNPs, I said those are the ones that it's going just to request the missing LSPs. Let's say, for example, I receive a CSNMP from my neighbor. Let's say as a CSNMP of 10. And then maybe for me, I had a CSNMP of 6. So I'm going to send a PSNMP to my neighbor telling them, by the way, I am missing 7, 8, and 9. Could you send me? So that is the work basically for the PSNMP. So basically, just the LSDB synchronization is just to make sure that the topology view from each and every router is identical. We don't so that we don't have a situation maybe a link has gone down and maybe the other routers are not aware. So basically, it's just the synchronization is going to prevent such a situation from happening. Now, let's go to ISIS cost. And actually, ISIS being a link state routing protocol, you will find that each and every link has been assigned a metric. And these metrics, there's always, there must be a rationale for you assigning maybe a certain metric to a certain link. Let's say, for example, I have 2 links. Maybe I have 2 links to reach router X. Maybe one of the link is a microwave link, and maybe another one is a fiber link. So, basically you'll find that the fiber link is always, maybe it's more stable compared to the microwave link. Also, the fiber link maybe could be having a higher capacity compared to the microwave link. So for that one now, I may make the microwave link to have a higher cost. So basically, if I put it to have a higher cost, I'm just telling you, please avoid using these routes, maybe because maybe it is of low capacity, or maybe it is not stable. Also, maybe the things that actually could drive you in deciding the cost that you're going to put on a certain link is also maybe the latency. Maybe the link might be stable, yes, but it's having a high latency. So maybe I may, now if I have a latency sensitive traffic, then maybe I may decide to put maybe that link to have maybe a lower cost, maybe as much as it's of low capacity, but the latency is low, then maybe I may put it as to have a low cost. So in ISIS, it's supposed 2 styles. So we have the narrow metric, and we have the wide metric. And what usually happens is the difference is now when it comes to configuration of the cost. So if I've employed a narrow metric on my ISIS, the type of the cost I can configure is between 1 up to 63. If I've used a wide metric, I can configure 1 up to up to uh, up to 8 million. And you'll find that also now when it comes to a cost range. Let's say, for example, you have like a chain. Just think of it like you have your routers on the ring, and I am using maybe in that ring I am using a narrow metric. So the bits allowed for narrow metric is it's allowed 8 bits. So if you say 2 per 8, I think it's around 1024. So if I add the cost along that ring, and maybe it exceeds 1023, and I've configured a narrow metric, and even the router, maybe the upstream router has also a narrow metric, and it receives a link, maybe, and the link is maybe having a cost of maybe, let's say, 2000. Basically, that router is going to drop it's not going to accept that LSP, because it's already exceeding the 1023 that is already defined in the narrow metric. So basically, for narrow metric, you can use it in a small network, ideally, but for wide metric, you can use it in a large network. So because actually the cost, I think this number is it 4 billion? 261,412,864. So that's the amount. The cost may increment up to that number. So another thing that you need also to consider, I think also when it comes to adjacency formation, if you have a narrow metric on one side and a wide metric on the other side, I really doubt if it can form an adjacency. And then also on the TLV support, the narrow metric doesn't support it doesn't support. Let's say, for example, you want to do maybe traffic engineering. Maybe you want to color your traffic. Let's say maybe your latency sensitive traffic, maybe the one that require high capacity. You might not be able to do it in a narrow metric, but this is possible in the wide metric. So basically, at the moment, the best practice to use is always use the wide metric in your ISIS network. Now, we are now going to route calculation. And when it comes to the route calculation, this is where now the cost now comes very, very handy. And for ISIS to calculate its routes, it always uses the shortest path first to calculate the routes. And you will find now, remember we've said that each and every router, let's say for example, we are in a domain, maybe it's a core network. It has all the LSDBs are updated, and each router is going, it has received the LSDBs, it has received maybe different routes to maybe reach maybe router Y. Let's say for example, uh, device A wants to reach device D. So device A knows I can either, it has received an LSDB telling them you can go to B, go to C, and you'll reach D, or you can go directly to C and you reach to D. So it has all those, it has all the LSDBs in on their database. So what will happen is router A is now going to, it's going to draw a tree. It asks itself, okay, let's assume, for example, I'm going to D and I use the route via C. So the cost to C is 2 and the cost to D is 3. So the cumulative cost, we get that one is 5, correct? And then you have another route. Go to B first, that is a cost of 1. Come to B, a cost of 5, that is 1 plus 5, that makes it 6. And then go to D now, a cost of 3 from C to D. So that is going to be 9. So it knows that if I use B, the cost is higher. So now it's going to now come up with a tree and say the best route to reach D is via C. And that is now, when we come to the diagram below, you see now it has said to reach D, I'm going to use a C. And to reach B, I am just going to use my direct link to B, because actually to reach even B, it has 2 options. It can either go to C, which is 2, and then go to B, which is 5. So 2 plus 5 is 7. And then it compares the other cost. The cost from device A to device B is 1. So which one is lower? Of course, the lower one is the one on the cost one. So basically, when it draws that tree, it's going to say, okay, I can reach, the best path to reach to B is my direct link and not going through C. So each and every router is going to do the same. And it draws that tree. And now let's say, if for example, now let's say we lose a link, then now it's going to, of course it's going to, on its LSDB, it's going to receive maybe an advertisement telling them, okay, maybe link to C is now down, and your best path to reach, you actually, it's not even a matter of best path, because actually he only has one path. So you will know to reach D now, I'll have to go to B, C, and then finally to D. So that's how actually ISIS calculates the routes. So for this scenario, it's like we've enabled the cost ourselves on each, and we've specified the links, the cost for each link specifically on each router. But you may find, let's say for example, you don't want to involve yourself like trying to manipulate those traffic. You can on the interface level, you can enable ISIS auto cost. So auto cost works this way. Let's say for example, the link, let's say the link between A and B is a 1 gig link, and then the link between A and maybe C is maybe a 10 gig link. So basing on that bandwidth, it's going to calculate, the router itself is going to calculate the cost. So of course, if it's a higher bandwidth link, then the cost is going to be lower. But if it is a low bandwidth link, the cost is going to be high. So, but mostly on service providers, I always see is actually most preferred way of influencing cost is mostly on you yourself taking that initiative, deciding actually to reach this device, this is the cost that I'm going to implement. So the next thing that we are going to check is on the advanced features. That is on ISIS. This is on ISIS route leaking. So we just have a diagram for that. Okay. So we said you remember we said the L1 only knows the routes. It knows the routes within its only area, and then L1, L2, it knows the routes maybe for different areas. And we said for an L1 router, let's say an L1 router has connected to an L1, L2. So what will happen is the L1, L2 is going to add, it's going, when it's sending the LSPs to L1, it's going to send an attached bit. And the attached bit has the default route to reach the other areas. So that is by default. But let's say, for example, you would like to do some traffic engineering, assuming like let's say, for example, L1 has two links to maybe L1 to maybe an L1 router has connections to as a connection to one L1 L2 router and another connection to another L1 L2 router. So instead of just you L1 L2 router sending the specific the default route to the L1 router, you may want to now start importing you may want maybe start exporting the routes. And when you're exporting the routes, let's say, for example, you are exporting the routes maybe with a certain cost. So maybe on the other side, maybe you may say, okay, these routes maybe it adopts maybe a cost maybe of 100, maybe the other one 200. So by that, it's going to enable you to do the traffic engineering. So actually, the route leaking, just instead of using just the attached bit, just sending the default route, it's better to use you do the route leaking. And you can now try to do the traffic engineering. Let's take, for example, this one. This one, like for this area, router E and router F, they are both L2 routers and they are in area 20. And then we have router D and router C. So router C and router D are L1, L2 routers. So basically, these are your aggregation routers, and then the router E and router F are your core routers. And then now router A and router B, those are your those are your L1 routers. And as I told you, L1 routers, they only know the routes within their area. So basically, router B and router A, they know areas just within area 10. It has no idea about the routes in area 20. Those are the routes belonging to router E and router F. So basically, you may want to import those routes. So basically, in Huawei VRP, this is the syntax that you use to import Maybe I can just, let me just show you another diagram. Just a minute. Give me 1 minute. So let me reshare my screen. Just confirm my screen is back. Okay, thank you. So this is, let's say, for example, this is an example of a network in a service provider. So we have the access processes, and the access processes is the ISIS 5 and the ISIS 7. And the actually, I can say, you see these routers, the ATNs are the ones we can call them the, let's say we can call them the L1 routers for now. These are on the access level. And then you have your ASG and the RSG. These ones are your core routers. We can call them the L1, L2. And then, so what usually happens now, ISIS 100 is our core process, and ISIS 7 and ISIS 5 are your access processes. So you will always find, like, when it comes to, let's say, for example, you remember, let's say, for example, the route reflection and the stuff, the BGP route reflection, you'll find that the RSGs and the ASGs always act as RRs to the downstream. So what usually happens is, now you will find that the best practice, actually, you always use, when it comes to BGP formation between the ATNs and your aggregating devices, you always use the IP address configured on, let's say, for example, you've configured an IP on loopback 0. But now you find that loopback 0 is operating on ISIS 100. But now the link between the aggregator and the ATN are operating in an access process, which is ISI 7. So for you to establish a reachability between the ASG and the ATN, the reachability of the loopback, the ASG loopback and the ATN loopback, then you will need now to do the route leaking. So you will find, actually, what usually happens is the loopback of the aggregator is going to be is going to be leaked into the access process. So you remember I said loopback 0 it's on ISIS 100, but I'm going to leak it to the access process so that the ATN, which is on the access process, using the ISIS process on the access, can be able to reach the ASD loopback. And then now I'm going to leak the routes on ISIS 7 to my core process, ISIS 100, so such that my core router can have the full view of the network. So let's assume, let's say for example, let me change this. just let's assume this was just a minute. Just let's assume this one was not ISIS 5. Maybe this is ISIS 6. Okay. But this ASG wants to know maybe how can I access this ATN here? And it doesn't have ISIS 5. So since already ISIS 5 was already linked in the core process, okay? So it means that ASG, okay, will say, okay, if I want to reach devices configured on ISIS 5, I will go back to the RSG, and then I come down to the ATN. So basically, you will find this is the most used approach in service providers when it comes to route leaking, whereby you leak your the loopback 0 IPs to the access, and then the access process you leak it into your core process. Your core process now being the ISIS 100. So let me go back to my presentation. Just confirm if you can now see my screen. So actually we are almost at the tail end. Don't worry. I know some of you want to go and watch football, and maybe you have some something to do over the weekend. So we actually are at almost at the tail end. So we are now going to see a comparison between ISIS and OSPF. Remember, we mentioned when we were starting the presentation, we said ISIS is a link state protocol, and also OSPF is a link state protocol. And they both use SPF when it's calculating the when it's doing the route calculation. But now, what is the difference between ISIS and OSPF? What would make you to say, okay, for my network, I am just going to implement OSPF, or for my network, I am just going to implement ISIS, or I am going to use both. So we are going to see what could be the drivers for you to decide from using ISIS, or maybe deciding on using the OSPF. So when it comes to the biggest differentiator between ISIS and OSPF is on hierarchy. So you'll find, like, let's say for example, for SPF you'll always have an area 0, and you'll find your areas actually they must have a way how they can connect to area 0, which is your backbone area. And if you don't have a direct link to area 0, then maybe you may need to implement aspects like the virtual link. So the virtual link, if you don't have the direct link from, let's say, from area 1 to area 0, then you may create a virtual link to area 0. But now when you come to ISIS, that's a bit different. We can say we have only, it's a 2-level hierarchy, whereby we have the L1 level 1 routers, and then we have the level 2 routers and level 1 2 routers operating at the core. So basically, when we compare the two protocols, the OSPF and the ISIS. So basically, OSPF usually operates on the layer 3, that is on the IP, and then ISIS is on layer 2. You remember before I told you, when it comes to sending the hello packets, it always uses a multicast MAC address, and you will find a multicast MAC address for a point-to-point network and a different multicast network for a broadcast. So actually, this feature makes makes ISIs a bit, I can say, it's actually makes ISIs a bit secure, since the ISIs cannot be vulnerable to DOS attacks, since it's actually operating on layer 2. Then on IPv6 support, so you will find that, for, let's say, for example, you want to you have on your network, you want to run IPv6 and IPv4. So for OSPF, you will need to run two separate processes. So you'll need to have the OSPF version 2, OSPF version 2 being your IP for IPv4, and OSPF version 3 being your IPv6. So you will find actually, but for ISIS, it's just the same. You'll use the, if it's ISIS 1, you'll just go to your interface, configure your IPv4 address, configure your IPv6 address, enable your ISIS process there, and it is as simple as that. ISIS is going to advertise both IPv6 and the IPv4 address. So for configuration, it means actually you will need to configure a lot of things if you are if you want your network to support both IPv4 and IPv6 in OSPF. But for ISIS, just that simple process, that single process is in a position to support that the two processes at a go. So it actually, it can do the dual stack. Now, I remember someday we had one link was down, and we had set up ISIS to support the IPv6 and the IPv4. So I was wondering, why is it that my IPv4 MPLS traffic is not failing over to the secondary link? And when I check now, when I check the adjacency, and this was in an Huawei environment. If you check the adjacency, it's telling you the PI is up. But the mistake that we had done is on the configuration of the IPv4 address. So on the other side, we had, so the IPv6 was configured correctly, but the IPv4 address were in different, they were in different networks. So the IPv4 was down. So, but if you check the adjacency, it's up. So for when you are working in Huawei, in a Huawei environment, just display ISIS interface. So when you display ISIS interface, it's going to show you clearly, okay, for IPv4, the interface is up, but on IPv6, maybe it is down, or the other way around. On IPv4, it's down, on IPv6 it's up. So now, for once you get to know that, then you'll be able now to go and check, why is it that my IPv4 is down, but IPv6 is up. But if you just display the adjacency, you might not really be able to know what could be actually maybe stopping your traffic, maybe from failing over to the secondary link. I am not sure if that is the case in Cisco. Anyone, maybe if you've worked in Cisco environment, I don't know if that is the case as well. But for Huawei, consider that. Don't just check on the adjacency. Check also on the interface, because actually for the interface we configured IPv4 and IPv6. So check on the interface level. Are both protocols, are they up, or one is down? If one is down, then maybe you may need to check why, actually what could be making a protocol to be down. Then on the hierarchy, for OSPF, you need it has the area 0. The area 0 is it's like now the core. But for ISIS, it has the two levels, that is the level 1 and the level 2, and level 2 being your core. And also they actually, you don't need it to be contiguous. Like let's say, for example, if you in OSPF, if you have an area that does not have a direct link to area 0, then you might need the virtual link, but this is not the case in ISIS, because actually your level 1 2 router can do the linking seamlessly. Then on the roles, on the router role, so for OSPF, you will always find the router is actually the router is in a specific area. But for ISIS, the demarcation is actually on the links. So you may find maybe this link is in area 6, area another one is in area 5. But for ISIS also, the router will always be on on a certain area. So the next is on. So the on the DR, BDR, and the DIS election. So for this actually now applies on the broadcast network. And let's say, for example, for in OSPF, if a router has been elected as a DR, it means actually that it will always be the DR, and until just a minute, just let me just reconfirm this. So if a failure, like let's say for example, a new router with a better priority comes to in a ISIS broadcast network, it is going to be elected immediately as a DIS. But for OSPF, once it is elected, it's until maybe it fails, then that is going to change. Then on the database unit, you'll find actually OSPF has many LSA types. Like for example, you have the router LSA, just maybe giving you the state and the cost of the links that router has. You have network LSAs, you have summary LSAs. So you will always have many LSAs, but for ISIS, it depends on the level. So if it's a level L1, L2 router, you'll always have a L1 LSDB and L2 LSDB in the router. But if it's just a level 2, you'll only have a level 2. But if it's a L1, you'll only have a level 1. So a bit when it comes to the database, ISIS is a bit simpler compared to OSPF. So addressing and discovery. So ISIS mainly operates on the CLNMP. This one now, remember, I think for ISIS, you remember the way you always come without the network entity. But for this one, it's just going to use the IPv4 or IPv6 addressing for router when it comes for router IDs. And it always, like for example, when it comes to the selection of the router ID, it always check. I think the first one should be, if you specifically configured the router ID, then that one is going to be the router ID. But if you've not explicitly configured, then maybe it's going to check the highest IP of a loopback configured on that router. If we don't have a loopback, then maybe it's going to check a physical interface with the highest IP address. That now becomes your router ID. And then on the network types, you will find there are many networks in OSPF. And for ISIS, you'll only have 2, that is the broadcast and the point-to-point. And then on the database granularity, you'll have many LSAs in OSPF, but for ISIS, you'll only have level 1, either level 1 LSP or level 2 LSP. And then for OSPF, it uses a fixed packet header format. But for ISIS, it uses the type length value. And actually, this feature makes, I can say, it makes ISIS to be, I can say it's a protocol that can support maybe if you need to add maybe a new thing, then you'll just have to add just on the, you'll just add, just have on the TLV, you just create a new TLV, and then you say maybe this TLV is to support maybe function X or maybe function Y. But for OSPF, for you to introduce a new function, then you might need now to have a new LSA that is going to support that function, and for that case, maybe you need to talk with the IETF for you to do that. So on convergence, so actually, yeah, this one is relies on SPF shortest path fast tuning, and then the other one is ISPF tuning. So what happens is, let's say for example, a link has gone down, then the LSDBs are going to be sent, but for OSPF, it's going to do a calculation of all the routes. But for ISIS, it's just going to just check on the ones that are affected. So this one actually makes ISIS, I can say, to have better convergence compared to OSPF. Then on the refresh, database refresh, it's actually, you'll find for OSPF, they will always refresh after 30 minutes, but for ISIS, it should you always have a lifetime of 20 minutes for the LSPs to be refreshed. And then for on scalability, this one is better suited for a small network, but for ISIS is more scalable and very effective when it comes to a larger network. So the last thing that we're going to check is on why do service providers mainly prefer ISIS over OSPF? So when it comes to hierarchy, the ISIS is a bit simpler compared to OSPF, whereby you might have a link. If you don't have a direct link to area 0, you might need to configure an, a virtual link. And then for this one, when it comes to addressing, so now when you are designing your network entity, you'll always define the area, and also the system ID. But for OSPF, just uses the simple IP address. Maybe you've configured, like, let's say for example, you've configured your router ID, maybe 1.1.1 or maybe 2.2, or maybe if you haven't configured, it's going to follow that hierarchy of maybe checking the IS loopback address. If there's no loopback, check on the IS physical interface. But for this one, for ISIS, you must specifically you must specifically state it. And as you can see, the entity is actually, I can say it's carrying a lot of things. It's not just the system ID, it's also carrying up to the area. So we can say when it comes to identification, ISIS actually has a better edge compared to OSPF. Then also when it comes to metric, depending on the metric that you choose, let's say for example, if you choose a wide metric, you can configure any metric from 0 up to 16,777,215. But if you choose a narrow metric, then maybe now it's like you are not really actually utilizing the best of what ISIS can offer. But for OSPF, it always uses mostly it uses the bandwidth when it comes to determining the best route. So you will find the ISIS still has an edge. Scalability, ISIS is better in large networks, but for OSPF still good, but the LSDB gets bigger and bigger as depending on like the number of routes that you have in your area. But for ISIS, you can control, especially when it comes to now when you're doing the route leaking, you may decide, okay, I want to leak this and this and this specifically. So you may find actually the LSDB is smaller compared, let's say for example, in your access area, maybe you have a router that is not really that powerful, then actually ISIS is actually going to be more be more efficient compared to OSPF. And then on the flooding mechanism, you'll find the ISIS. You'll have it will have it will always have the LSPs. LSPs actually is going to have the metric, the prefixes, the neighbors connected, and prefixes, neighbors. That's basically you're going to have on the LSPs. And then for OSPF, it uses LSS, and we said they have many LSS. So for ISIs actually is a bit simpler because actually the LSP is just either level 1 or level 2. So it's a bit, we can say it's simpler. On network types, ISIs only has two network types, that is the broadcast or point to point, but for OSPF, many network types. So ISIS is still simpler. Traffic engineering, the ISIS, the type length value enables you, maybe you can introduce maybe a new TLV. Maybe let's say, for example, for things like SRv6, SRMPLS. So those TLVs actually is going to, you can implement them in ISIS, but for OSPF to add new features, maybe let's say, for example, for SRv6, maybe you would like maybe to advertise your prefix seeds, adjacent link seeds. So it might be a bit difficult to implement the same in OSPF compared to ISIS. Also, route leaking is a bit simpler in ISIS compared to OSPF. And finally, the protocol support also, if you compare OSPF and IPv6, and OSPF and ISIS in terms of supporting IPv4 and IPv6, you remember we said if you want your network to be using IPv4 and IPv6 at the same time, you will need two different processes in OSPF. So you'll have the OSPF version 2 and OSPF version 3, but for ISIS, it can dual stack, so it makes it a bit better compared to OSPF. Then a summary of the same. So the decision now, when it comes to making the final decision, if you are, maybe you're working in a campus network, maybe just an enterprise environment, then maybe you may want, OSPF may serve you well. But if you are working in an environment that you need to support IPv4 and IPv6, and you want to do this seamlessly without a lot of effort, then your best protocol is ISIS. And also, depending on the number of routers that you're going to have on your network, if you're a carrier, then ISIS is better. And also now, when it comes to the new features you want to support, then ISIS is also going to have a slighter edge compared to OSPF. So I think up to there, we can call it a day. Maybe we'll have others, maybe someday, maybe we can now get our hands dirty. We now do the configuration. We see actually what happens. We try to see, maybe let's say what could, when maybe you are doing the route leaking, how do you do this practically? So maybe in future, we may have a session whereby we can now do the practicals. So I invite questions, and maybe also if you have something maybe you would like to add, maybe I might have missed, you may also add.
Yes, so from my end, going back to that interesting scenario that you gave, of the ISIS links not being able to fail over,
Mm-hmm.
where you mentioned that the IPv4 network was down, but the IPv6 remained up.
Yes.
I've seen that scenario on OSPF. Um, so back then with OSPF, if you had an IPv4, if you have an IPv4 process in OSPF, if let's say you wanted to run IPv6 back then, you were required to have two processes. The
Yes.
first process of IPv4 and second process of IPv6. But now for the new iOSs, I think from iOS version 15, yes, version 15 and above, Cisco introduced the multi-address family OSPF, where you can run IPv4 and IPv6. So in that process, what I saw was the IPv4, like what you mentioned with ISIS, was down, and then OSPF used the LSA Type 8
Hmm.
to you to play the role of the keeper lives. So you'd think that OSPF is up, but the IPv4 is not functional. But IPv6 is keeping the adjacency up. So that's the scenario that I saw, and it becomes extremely complex because like what you mentioned, you'd think the adjacency is up. Yeah, that is what I saw from my end. Yeah.
Thanks a lot, Martin. So it's the same thing for both Huawei and also uh, Cisco.
Slightly slightly different.
Hmm.
Yeah, slightly different. I would say, I would say, um, like what you mentioned, ISIS on Cisco, it is, I would say, it can be quite complex when it comes to protocol naming conventions. From what I saw, especially in the ASR 9K. But what I appreciate about Huawei is that they make the uh, the the naming convention simpler. You know what you're working on. That's what I've noticed about Huawei.
Yeah, sure, sure.
Edwin, I see your hand is up.
Hello, yeah, I want to ask one question to Theo. Thank you, Theo, for the good presentation. So I want to ask about the differences between ISIS and OSPF when it comes to root leak. How is it? Is it to leak on ISIS, and how difficult is it to leak on the OSPF? Like the complexity, is it because of the segmentation of the area, or how is it? How does it work? Maybe you come across such, just for my understanding.
Okay. So actually, I've not done so much route leaking when it comes to OSPF. I've actually been doing more on ISIS, but you'll find actually you'll always do the route leaking in OSPF on the ABR. That is your area border, the area border router. And actually, you'll always find actually when it comes to calculation of the costs, it is solely left for the area border router to do the calculation itself. So basically, the network, I can say the routers on the downstream might not really have a view of all of, okay, let's say for example, so since the area border router is the one that has done the calculation, maybe it's now going to send a specific route to to the downstream routers. So but for so actually the downstream routers might not really have the visibility of maybe, okay, we had another route. It's just going to send the specific route that the ABR has selected. I don't know if anyone has done also some route leaking in OSPF. Maybe you can just share your experience.
Yeah, I I have done that, but with OSPF, it can get complex. But I've done it in Cisco and Huawei. So on the OSPF process, let's say, for example, you have OSPF 100 and you have OSPF 300. So how you do the route leaking, you can do conditional route leaking or unconditional route leaking. So say, for example, you do not want to leak the entire process. Let's say you want certain routes coming from process 100 to be imported into 200. So in Cisco, you can either have a prefix list or an access list, and then you tag the required routes. And then in process 200, you can specify the command redistribute OSPF 100 and then route map that calls out the route map that has the prefix list or the access list. And then also in vice versa from process 100, you can do the same in importing routes coming from process 200. And then in Huawei, instead of applying redistribute, it will be in import route, and then it will be OSPF, and then you put in the process. So that'll be the difference from what I know.
Okay, can you maybe, I don't know if you can touch something on OSPF in terms of loop prevention? Okay, but before you go do that, maybe I can also explain in terms of how does ISIS prevent a loop from being formed. Let's say, for example, you've leaked a route from L1 and from an L1 area to an L1 L2, and then maybe it has been advertised to an L2, another L2 router, and then that maybe on the downstream also there's another L1 L2 router advertised to an L1 area, and then you may find a situation maybe the L1 area now start re-advertising the same prefix back to L1 L2. How do we prevent that loop from happening? So when it comes to loop prevention, there are two bits. There's an up bit and a down bit. So the up bit, let's say for example, if you are linking a route from L1 to L1 L2, it will be the bit will be set to 1, and no, it will be actually it's set to 0, and then when you are linking it to another L1 L2 router, it's still going to remain to 0. But now when it's going to be linked into another, now when the L1 L2 router is linking it downstream to another L1 to a L1 router, it's going to set it as an up bit, so the bit is going to be 1. So but now the L1 router doesn't understand these bits. So when it tries to re-advertise back the route with the advertise the route is already has a we have the app bit attached on the route. So basically the L1 L2 router is going to drop that route because actually it sees the route is already set on 1. That is basically how we prevent a loop from being formed on between the when we are doing the route leaking between the L1 and L1 L2 routers. I don't know how that happens on SPF. I don't know, Martin, if you could be having an idea on that.
OSPF, oh, there's a lot of variances, but I'll mention a few. Uh, it also depends on the design. So say, for example, OSPF 100 has routes that are coming from area 100, and then process 200 has routes that are coming from area 0, as an example. and let's say routes that are coming from area 100 being leaked into another process. OSPF will say, okay, if you're coming from if you're coming from another area and I'm receiving the exact same route but coming from my own area, I'm going to ignore the route that's coming from another area because the route that is tagged as an intra area route will be more preferred. That's the first scenario. Then the second scenario is when you have an OSPF stub. So the OSPF stub will say any any routes that are coming from LSA type 5, I am going to reject. Um, and then if you have not so stubby, and LSA type 7 is not allowed to leave an area, then that's another loop prevention. But what it does is it will take the LSA type 7, translate it to the LSA type 5 using the P bit or the propagate bit. And then in return, the LSA type 5 to LSA type 7 is disabled for loop prevention. So those are the scenarios that I can give. But it's the sorry, and then the other one is the PECE scenario when you're running OSPF. So that scenario is if let's say you have a PE router and a CE router, OSPF is running on the PE side with a VRF, and the customer side is running OSPF. So what's going to happen is OSPF on the PE side will use the downward bit to prevent that loop.
Right. Thanks a lot, Martin.
Your hand is still up. You have another question? Any other question from the audience? Yes, Olaimi?
That's all from me. Martin. Also, I wanted maybe to ask the team if you have like an online what can I call it? Online somewhere where we can get more resources, even labs to do uh, some labs, etc. You can also share so that we remain informed. Thank
Actually,
you.
from the channel, you should be able to get so many labs on different vendors. If you just check it out, you will be able to find them. And yeah, on the WhatsApp group, there are actually so many resources that are shared, which you can also explore. Olaimi,
Okay.
you are asking your question.
Okay, I don't want to ask about OSPF route tag. What about it? As Martin's explained the damn bits, maybe it could be explained too.
Motiva, you have a question here.
Oh, sorry, I didn't catch that.
He's asking
It was a bit of
about
a starter.
the OSPF route tag. Maybe he wants you to explain more about it.
The OSPF route tag. Um, the OSPF route tag, in most cases, you can use it to either uh, prevent routing loops when you want to run mutual redistribution, or if you want to uh, um, export routes, you can have an access list, and that access list you can then um, match it up in the route map, And then that route map, you can give it an OSPF tag. And then instead of exporting the access list, you can tell your neighbor that I am going to give you a tag rather. But that scenario, it doesn't always work on OSPF. But short answer is the OSPF tag can be used for route manipulation and route filtering. Hope that answers the question.
Yes, thank you.
So, Elisa?
Yes, Martin. Uh, and I just want to address the question to the teacher. It is about the design for when it comes about ISIS. And the design is about levels, level 1, level 2, level 3. I mean level 1, level 2, and level 1 and 2. So is it fine if I keep the entire network on level 2? Is it fine? This is my first question. Then I can ask the second one, please.
You're asking if it's fine if you put your network to be?
If you can put
The
all
network to
your
be, the entire network to be on level 2.
So if you put your entire network or as a level 2, I don't think it's a best practice, because actually maybe you can use a level 1, level 2 so that you can perform the route leaking. But let me just confirm that. Actually, you remember the let's say, for example, if you put your network as a level 2, it's just, I can say that your network it looks like a flat network, eh? So it means actually all the LSDBs, actually each router must process all the LSDBs. So I think actually you'll be actually on the CPU utilization, I think you'll be stressing your router. So I would prefer actually you segment. You have a level 1, level 2, and also level 1.
Okay, thank you so much. My last question is the reason why most of the time companies or enterprise they choose ISIS instead of OSPF. Is it about so many packets processing on OSPF and less packets on less updates packets on ISIS? Is it the main reason of OSPF too many packets and ISIS less packets than OSPF? Is it the main reason people choose ISIS instead of OSPF?
Actually, the main reason for maybe using ISIs in a service provider network is the TLV feature for ISIS. It means actually it can support many features. Let's say, for example, initially maybe you are just using normal MPLS in your network, and maybe you would now maybe want to migrate to maybe segment routing, or maybe you want to implement SRv6. So ISIS is actually, I can say, it's going to be able to seamlessly support the new features in your network compared to the OSPF.
Okay. And when it comes about updates, packet updates, when the link change, when the topology change, so is it the same with OSPF and ISIS
No,
because
it's
of
not.
putting so much pressure on the CPU of the router?
it's not the same. So you will find OSPF ISIS uses the incremental. Let's say, for example, you have a link change, so it's going just to recalculate the only affected area. But for OSPF, the whole there will be it's going to do a recalculation afresh on all the links, despite that the fact that maybe it was not affected. So
Okay.
the incremental feature for ISIS makes it better when it comes to, it makes actually you can say it makes your CPU utilization to be a bit low compared to OSPF.
Okay, so that means if it's making the CPU to be less than OSPF, that means ISIS is better than OSPF.
Yes, ISIS is better.
Okay, thank you so much. And you mentioned something. You said that the incremental or something you mentioned here that is higher than ISIS for OSPF.
So when I said incremental is like it's just going, it's just checking on the links that are only affected. It's not checking the whole links that have been installed on the LSDB.
Okay, thank you so much.
Any other question from the team? We're nearing the end of the session. So,
Hi, Martin. Martin.
hi, David.
Sorry, I'm using my phone.
It's
I was
okay.
looking for a place I can raise my hand. I
Okay,
don't seem to see it.
proceed.
Um, two things for me. Not a clear question, but just two things for me. Number one, I think there should be clear the difference between the route leaking and the distribution. Maybe that's something Theo can, if he has another chance to come in and do the lab, he could maybe touch more about, because I'm of the feeling they are very different. They are maybe similar, but they are very different. For example, in Huawei, when you're doing route leaking, my understanding is that it's only done on L1, L2, and that is simply to just enable L1 routers to be able to have the routes from L2 routers. That's my understanding, and it's different from the distribution. And one thing I can say is that I think route leaking is mainly done within the same process. Um, that is on L1, L2. Number two, I wanted to just answer Elise. There's a question he asked if it's okay to run L2 only router in a network. And for me, the answer is it depends. I can speak based on where I currently work, where we it's a service provider environment, and all our routers are SIS level 2. So it depends on how your network is structured, or what you want to achieve with the network. That's it.
Thanks a lot, David. Just also to add on the redistribution and route leaking. So basically, mostly on redistribution is between the protocols. You could be having, maybe you want to redistribute maybe ISIS routes to maybe to BGP or maybe to OSPF. But on route leaking is just between the levels.
Thank you for that. Anyone else with a question?
Hi,
Yes, yes.
Martin. There is a small question. Sorry.
Yes.
What about the loop prevention in ISIS? Is it same like OSPF, or is it more optimized here? Just a brief answer if you can.
Pardon, I didn't get your question clearly.
Hi, my voice is clear.
Yeah, I can hear you now.
Yeah, I'm saying that what is the mechanism for loop prevention in ISIS? If you can comment on it, is it same like OSPF, or is it more optimized?
Yeah, for loop prevention on ISIS, it's mainly using the down bit and the up bit, and you'll find, let's say, for example, if I had received a route from an L1, I'll always attach, I think it should be down bit when it's going to from L1 to L1, L2, and then from maybe another L1, L2 to maybe to another L2, and maybe downstream to another L1, L2, and then I advertise another L1. Then maybe I'll going to another L1. I'll make the bit to be now. It will be up bit. It will be one. So, but the L1 router doesn't understand that bit. But if they try to advertise to me, I'll see that this route already has an up bit, and I'll just refuse. I'll know actually. This guy is trying to re-advertise another route, the route actually that I had sent it to them. So that is basically on loop prevention on ISIS.
Okay, thank you.
Blimey, your hand is up.
Okay. Does sequence number and aging also play a role in loop prevention in OSPF and maybe ISIS? Sequence number and aging.
Yeah, it does play. It does play a role. Let's say, for example, I receive an LSP and I find maybe my neighbor maybe has a sequence number, let's say 400, and maybe on my LSDB I had a sequence number of let's say, for example, maybe 60. So for that, I'll know actually the sequence number is actually going to assist me, because the low sequence number, it's actually it's like it's telling me, okay, you already have your LSDB is a bit old, so I'll just request via the PSNMPs, and that actually is going to prevent the black holing of the traffic. But in terms of sequence number preventing the loops, I'm not sure about that. Maybe someone else can add on that.
OSPF doesn't use that to prevent loops.
Last question, please. If there is anyone who
Yes,
yes.
yes, Martin. A question from my end, Theo. My question is, say for example, in your MPLS core,
Mm-hmm.
like you have a lot of customers going through that core.
Mm-hmm.
Let's say, for example, um, with regards to congestion management, you want to prevent the ISIS traffic from being impacted by the customer traffic. Like for example, with the OSPF, you can mark the OSPF traffic with the IP precedence number 6 or CS6. But looking at the ISIS being a layer 2 protocol, how would you match the ISIS traffic in your quality of service to prevent the customer traffic from impacting it when there's congestion?
Okay, I think for on normal MPLS, I think that one might be a bit difficult. But if you do, like, let's say for example you've implemented the segment routing and the SRv6, I think you can try maybe color your traffic, and then now you can specify on the type of links that it's going to use. But I'm not sure if that for ISIS you can just do it natively without maybe without the combination of another protocol on top of it.
Okay. Of course, I'm still trying to do it because, the documentation stipulates that the ISIS the default marking is CS6 on the layer 2.
Mhm.
But cases where the CS6, when you match it, it doesn't always match it. So I was asking maybe if ISIS has a default packet length that you can match in the traffic classification.
Anyone, maybe if anyone could be having an idea, maybe can add on that. Maybe we can still do some research. We see how we can implement that on ISIS.
Yeah, no, it's good, cool. I can do more research. Yeah, but ISIS when it comes to traffic classification, it can be quite a challenge. But yeah, as soon as I figure it out, then I can update the group.
All right, thank you. Maybe if possible, Martin, maybe you can mark those. Then maybe in our next session we can review them before we
Yes,
start.
yes, I'll do that definitely.
Yeah.
Okay, I think Elisa, you have something else. I see your hand is up.
Yes, Martin. I just want to ask you the lecturer, is it possible if there can be a session that it can be just for how to calculate the system ID of ISIs? Is it possible?
Yes. Maybe
Is it possible to have that
Martin.
kind of a session?
Martin.
You can reach out to me. I will explain to you. I believe that way because that is always a straightforward process. We may not have a separate session just to show how to calculate the network entity, but yeah, I can take up that and explain it to you separately.
Okay, thank you. And also my last question, just one simple, small question. Most of the time when you speak with engineers, they always come that it depends with what you want to achieve. But no matter what I want to achieve on the network, am I not supposed to follow the standard of networking, or I can do whatever I want?
I believe there is always the standard, and then there is the real scenario that you have on the ground. That's why they will always tell you that yes, it depends on what you are trying to achieve. Sometimes you are not able to follow the standard, and you need to come up with your own workaround so that you can achieve your objective. So there is the standard, and then there is, normally we say it, I'm trying to find vile iko kwa ground. Theo, how do you translate that in, in English? Because
But that means, Martin, that means whatever that we are learning theoretically, it's nothing. You can come up with your own idea, and even if it doesn't follow the standard, you build up a network.
it's not cast on a stone. It's not cast on a stone. Some standards actually they are not best practices, and sometimes you need to. I remember there was a discussion in the group. Was it in the group about some best practices that are not really good for the network? So you need to modify some of these implementation so that they can fit to your network, Elisa.
Maybe I can give you an
Okay,
example.
okay, but it's complicated, Martin. Sometimes also
And the more you deal
At
with
least,
different networks, you will definitely agree with that. Sometimes you need to do everything possible just to bring up those services, even if some of those implementation are not best practices. So yeah,
Yeah.
It all
So
depends with
so
the
at
type of
least
network that you are handling.
yeah. So at least what I can say to you is that OSP. Let's say for example OSPF. I know this session is for ISIS. But let's say company A can decide to configure OSPF in a certain way, and let's say they follow the manufacturer's best practice, or they follow the best practice of the IEEE. Eh? And then you have company, let's say that company A, in order for it to follow that best practice, it also comes with a cost. I've seen cases where if you want to build best practice networks, you will spend a lot of money. Oh, is he still there? Oh,
I believe we
did he
should.
drop?
Yeah, this is the issue I'm saying. If you find some people they are doing things which is not according to the standard, but if you tell them to correct it, they say that brother, that is your theory, but things in the ground is something different.
Well, then the thing. This is how you think of it this way. When you build labs, and this is what I have faced when I was still learning networks. So when you build a lab, in a lab, it'll look so simplified. You can type in everything that you want to run and all that. But let's say now you want to take that very same principle, now you taking it to the field. Now in the field, it's all about, okay, so what type of routers are you buying? Okay, then what licenses must you run in order to achieve A, B, and C? You see what I mean? What type of links are you on? Like, let's say um, ISIS is ISIS when it comes to link types, it's more flexible than OSPF. You see what I mean? So there will always be a differentiator in in the field, and that differentiator is cost. Networks that are built in best practices, they cost a lot of money. So companies sometimes they don't always they don't choose to build networks badly. Sometimes they're doing that because that's what they can afford. And you'll find that what you're proposing, they want to do it, but they can't afford it. But what they can do, they can just apply workarounds just to keep the ship going. And then when the time is right, and then they they rectify it. And then also rectifying it, what you need to understand is when you rectify it, what are the risks of that rectification? um and when it comes to downtime, like how long will the downtime be, and how's the impact? So so from my personal experience, do not compare labbing with real world. You're gonna face issues. Real world, I would say, take the networking knowledge and the fundamental, and then mix it with the business perspective. If you do that, you'll understand why certain decisions were made.
Maybe I can give you another example. Let's say I have
Okay,
at least let's
yes, I
say
understand. I understand. You know what I'm trying to say is I'm not taking much of your time. I'm saying is when it comes about configuration, let's say logically, you see that things are not respected according to the standard of the technology. So you have to leave it because that is the way they want to do it, and they need to achieve something.
Thea, you can pick it up.
okay, let's take for an example. Uh, I am running a small ISP. I have a transit provider. Ideally, I would like that provider to advertise to me a full BGP table so that I can maybe decide on which maybe how I will be steering my traffic. But you see, let's say I have I have a low-end router that cannot handle a full BGP table. So for that case, I'll just tell that provider, just do this, just advertise to me a default route, and that will be okay for me. That is what my router can handle. So it's actually, as Martin mentioned, you must combine the business side of it and also the best practice. You must there must be some, you'll have to select one. Yes, it would be best if you advertise for me the full BGP table, but you see my router is going to crash. It can't handle the full BGP tables. So just give me a default route.
Okay, guys, I believe that should be it for today. And I again appreciate
Okay.
I appreciate your presence and attending this session. Theo, I believe you should be back with a multi-vendor lab on how to implement SIS. Today we focused just on the theory, but now we need to move a step higher and see how we do the implementation on different vendors, and then it will be very clear to many of us. I hope that is okay.
Yeah, okay. I'll plan for that.
Yeah, you can work on something multi-vendor. Uh, if you have different Nokia, Cisco, Juniper, Huawei, you can just mix and come up with lab so that we can be able to have some hands-on practice on the same.
All right.
Yes, Caroline, I see your hand is up. Caroline?
Okay, on my case, okay, it's my first time attending this class.
Yes, you're welcome.
I was requesting if you can get some resources based on the same.
Which resources?
For today class, the intermediate system to the IS to IS. Okay, maybe you can share the slides, the labs.
Yes, the
Consider,
slides. Yes.
considering also I'm a recent graduate, I don't have that much experience. I don't even have experience on the same. Maybe you can share for people like us.
Yeah, that's why we are here. We are here to help you also become a better engineer. The slides will be shared, the recording will be shared, and many other resources will be shared on the platform. If you are in our WhatsApp group, you always encourage to ask for resources, ask for materials, ask for clarifications, and people are willing to help you and to support you in your studies.
Okay, thank you.
You're welcome. I believe that should be it. Theophilus, thank you again for taking your time to deliver such an amazing session. I believe we've all learned a lot from the session, from the basics to the advanced features of ISIS, and we appreciate that. We appreciate your effort and even all those who've joined the session. AOB, anyone with AOB or Theophilus, if you have a word for the students, you can give your final word.
Thanks a lot for your audience, and actually, I appreciate actually that you've asked questions, so it means actually you are getting something, so it's a good thing, and I've been able also to learn something from you. So thanks a lot. I also appreciate your attendance.
AOB from any attendee.
From my end, Theo, I want to thank you because I can honestly say I've learned stuff that I honestly didn't know about ISIS. Because as for me, I work in the data center Nexus 9Ks. Most of the times, I don't always touch on that ISIS deep dive because I'm mostly touching on the BGP L2E VPN, the VXLAN and stuff, and then the ISIS is always on the underlay. So that's why I'm saying I've learned a lot today, and I want to thank you for that. Now it's pushing me to now want to know what's really happening under the hood. So thank you.
Thanks a lot, Martin.
Edwin, you had something to add? Or anyone else who has something to add before we close? Yes, Lewis.
That's okay. Or maybe I just had maybe just one question.
Yes.
Because I've been trying to check like what you posted on the YouTube, the links that you have been sharing, and I see that most of the resources that you have, they are mostly based on the IP, that's the Internet Protocol. I don't know if you also have like trainings or such sessions for transmission.
Yes, we'll be having some transmission sessions on DWDM at microwave in the upcoming sessions, but that will be communicated.
So okay, thanks very much. That's what I wanted to know, because that's where I'm strong at.
Okay. If you are strong, then maybe you can come in with a session on transmission then.
Yeah, sure.
Okay, last person. Anyone with AOB before we close?
Martin, from my end, I remember we did the OSPF session
Yes.
and on the lab scenario, I don't think we explored everything, but the guys may decide when would they like to have a full on lab deep dive of the OSPF.
Yeah, I can actually arrange for that also. Because even BGP, we also did the theory and it was more of microtic. So we'll be having deep dive lab session for ISIS, OSPF, and BGP. So let me work on the plan and then I believe you'll be coming in for that OSPF lab, right?
Yes, yes. The lab will be slightly different. I know last time I shared um, the topology that was more campus, but the other one that I'm going to use, it's going to be more service provider, but I'm not going to use the service provider route. I'm just going to use a normal iOS V that is more translatable to everyone.
That will be great. Okay, you can prepare and then we can link up and see when we can have that session. Olaimi,
Okay.
your hand is up. The last
Okay.
AOB, yes.
Okay, I want to ask if there will be a possibility to also have session on SRVCs, BGP, EVPN, VXLAN.
Yes, we hope to cover many of these topics, just that it will take time and we are starting from the basics. You can see that we even did subnetting. We need also to revisit maybe the OSI TCP/IP model. We've touched on ISIS, we've touched on OSPF and then BGP, so that we are evolving slowly. If we were to rush and have a session on SRv6, I believe many of us will struggle, but we'll definitely have those sessions on the advanced topics of routing and switching and even other transmission technologies. Hope that is in order, Olaemi.
Yes, thank you.
Martin, for the VXLAN, you can add me there.
VXLAN.
And yes, and then the BGP L2E VPN can add me there as well. But except segment routing, I'm not the best there.
None of us is best in any domain. I believe it's just about learning from each other, so don't worry. But I get it. Okay, guys, I believe that is it for today. Thank you so much for your time again. Thank you so much for joining and actively participating throughout the session. I hope to see you again. I will be sending the updates on when we'll be having our session and the topic of discussion. Thank you so much and enjoy your weekend. You can now go and cheer your teams. I hope all your teams will be winning, but I know, of course, they can't win all of them. May the best teams win. Thank you. And
Thank you, Brother Martin. Thank you, Teacher Philip.
Teacher Theo, Elise, not Philip. Thank you, guys.
Thank you.
And enjoy your weekend.
Thank you. You too.
Thank you.
Thank you all.